everyone. My name is Bryan Wilder. I'm an assistant professor in the machine learning department starting this semester. So I'll give a high-level sketch of the kinds of questions that I tend to work on. Really broadly, my work focuses on AI for social impact in some sense. And so the motivating question behind a lot of what I do is, how do we build AI which can be used to inform decision-making in high-stakes social settings, with a particular focus on the application side on problems in public health. And so that means that I work both on the sort of methodological side of how we build artificial intelligence that can function effectively in those settings, right? And the kinds of necessary technical properties to build that out, alongside working with collaborators to deploy these approaches in application domains of societal importance. So on the technical side, a kind of more specific way of framing what I do is around how we design systems that span the entire pipeline from data to deployment. And so that includes the process of modeling and immersion of the domain, gathering data, using that data to train machine learning models, using those models to inform decision-making via optimization, and then finally deploying the resulting systems out in the real world where they can have an impact. And so kind of stepping through the sorts of questions that arise along that process. So I tend to spend a lot of time working with domain experts, with community organizations, nonprofits, governments in these spaces in domains like public health or social work or related fields, and aiming to really understand what the challenges are from the perspective of those applications and what will make a difference on the ground, and then aiming to abstract out of that the underlying computational questions, or where we need to make methodological progress to drive those kinds of practical improvements. And so then continuing down the technical pipeline, so I work on problems around how we optimize the collection of potentially scarce data under resource constraints in these kinds of domains. So for example, thinking about how we collect data on social networks to inform preventative interventions, how we then use that data in machine learning pipelines, thinking specifically about questions like how we align machine learning with the needs of downstream decision making. So how we, for example, train models that incorporate information about the decision about how resources will be allocated that they're informing, how we incorporate that information into the loss function or the training of the model, how we build machine learning that's robust to the kinds of limitations that we see in data coming from these real world settings, and so on. And then once we have those predictions, using them via optimization to inform decision making. So thinking about how we inform the allocation of scarce resources in the design of interventions in settings like public health, which often requires optimization problems that model the objective and constraints of decision makers. And with a particular focus on here on topics like robust or stochastic optimization that allows to account for uncertainty introduced by the data and the upstream machine learning. And then finally, I work on deployment, right? So being able to evaluate these systems in the field in collaboration with partners in a given domain to be able to start by running pilot studies, to scale up to run controlled trials, and eventually deploy on a larger scale. On the application perspective, like I mentioned, I focused on public health. And so in the past, that's included problems like HIV prevention, and optimizing the deployment of preventative interventions for youth experiencing homelessness to disseminate information around HIV spread, working on improving adherence to medication in tuberculosis treatment in India. So focusing on how we can predict whether patients will adhere to medication in the future, and then optimize follow-up interventions by community health workers to keep patients in treatment. And finally, an array of projects around COVID-19, focusing on how we use the kind of messy data that's found in the health system and build the kinds of robust inferential methods that are needed to draw conclusions from it about how we track the burden of disease or understand how health disparities emerge in real time. So that's just a sort of sampling of the kinds of questions that I work on. And I'm, of course, always happy to chat if you're doing anything that's related. So.